Hello friends, in the last video we studied about how insulin transcribes gene, how insulin bind to their alpha subunit, bind to receptor of alpha subunit side, and at the beta side it phosphorylate and it phosphorylate another protein kinase. The first protein kinase is IRS1. It activate and when it activate SH2 domain containing enzyme. Okay, so here we will study about how insulin regulates glycogen. I hope this video is helpful for you. So let's begin this topic. Okay, the textbook. See, the next thing is when what happened. Not only the what I told, not only the here we will see glycogen regulation by insulin. See, as I told you, once the IRS is activated, okay, once this IRS1 is this protein is activated, it phosphorylated by what? Because of beta subunit of insulin receptor is phosphorylated, and that phosphorylate IRS1. Okay, so once IRS activated, it will active all the SH2 SH2 domain containing enzyme domain containing enzyme. Okay, so one example we saw, the one example what we saw, GRB2, right? GRB2 having SH2 domain. This is SH2 domain and it excited because of IRS1. Another example of that is let me take a different color for that. Okay, so now what? Another enzyme, the name of the enzyme is PI3K. PI3K. Okay, PI3K is what? It's a phosphoinositide 3 kinase. Okay, and now what this enzyme is doing? When this phosphatide 3 kinase is active, it will activate it will activate PIP2 to PIP PIP3. PIP2 is phosphatidylinositol 4,5 bisphosphate. Okay, and this is a phosphatidylinositol 3,4,5 triphosphate. So once this diphosphate is converted into triphosphate. Okay, when this triphosphate is formed in the cytoplasm, now it phosphorylate and activate other protein kinase. The name of the protein kinase, once it active, now it activate another protein. The name of that protein is PDK1. Okay, it is PDK1 activated. See here, as you can see. Okay, now this enzyme, one second, see what happened. When this enzyme is active, this PIP3 it activate, it bind to the protein, to bind to a protein. That protein name is PKB. Okay, protein kinase B. And when it activate, it phosphorylate this PDK1. Okay, so that will do another work. Okay, here we have to see protein kinase B, what it is doing. It activate glycogen synthase kinase 3. Okay, what it is doing? It is glycogen synthase kinase 3. Okay, it activate. And once when it is active, now this is active. How it is activated? Because of PKB. Okay, so make it little active like. Okay, this is active. Once it active, it phosphorylate glycogen synthase. Okay, now it become active. So now this is the phosphate group is attached. So when it is active, we it will stop the function of, see what the function of GSK3. It activate here, just write glycogen synthase function is it convert glucose into glycogen. Okay, it convert glucose into glycogen. Okay, so when it phosphorylate, when glucose phosphorylate, it become inactive. Okay, so what the function of GSK active? It phosphorylate GS and it become inactive. But when this is GSK3 is phosphorylate, it become inactive now. Okay, so when it become inactive, what will happen? GS will be free. Okay, it will not inactivated by this enzyme GSK3. So when it is not inactivated, what will happen? Continuous glucose will change into glycogen. Okay, got it this point? Actually, by the reverse way, we have to understand this. See, glycogen synthase function is what? It has to change. It has to change. See here, what is happening actually? Glucose change into glycogen. Glycogen with the help of glycogen synthase. Okay, with the help of glycogen synthase. But when this glycogen is phosphorylate, and it phosphorylate, then this action will be no more. Okay, this action will be no more. And who is phosphorylating this unit? Phosphorylated by GSK3 kinase. Okay, it's phosphorylated by GSK3. But when GSK3 is phosphorylated, now it become inactive. Inactive. Okay, when it become inactive, then it will not act on glycogen synthase, and it won't phosphorylate glycogen synthase. When it won't phosphorylate, then the glucose will continuous change into glycogen. Okay, this is the action. And who is phosphorylating? This is the normal action. Okay, in the normal condition, GSK is active, GSK3 is active, and with the help of protein kinase B, it will phosphorylate with the help of, see here, GSK3, it phosphorylate with the help of protein kinase B. Okay, that protein kinase B is, see, protein kinase B is active with the help of this active protein kinase is active with the help of phosphatidylinositol 3. It bind with the protein kinase B and it get active, and that activate this the further all action. So by that way, insulin regulate glycogen synthesis also. Okay, understood. See what all the process is active with the help of this IRS1. Once IRS1 is active, it activates SH domain containing enzyme. One example is GRB2, another example is PI3K. Okay, so this also containing SH2 domain, and this enzyme convert phosphatidylinositol bisphosphate into triphosphate that bind to PKB, and PKB will phosphorylate GSK3. Okay, once GSK3 is phosphorylated, now this phosphorylated will not phosphorylate glycogen synthase. If it will not phosphorylate, glycogen synthase will continuous active and it continuously convert glucose into glycogen. By that, insulin is regulating our metabolism. Okay. Now see here in this. Here is the insulin. These all are the insulin. And this is the receptor, insulin receptor. This is the glucose receptor. Okay, glucose is get inside in the body by the GLUT4. Okay. Now, once insulin bind here, it start gene expression and this, and it activate here that glucose receptor also. It activate glucose receptor and more glucose will come inside and it will convert into glycogen. This is overall the process of insulin glucose regulation. Okay, I hope you understood this all. If you're having any query, please write your comments in the comment box. Thank you.